Hello everyone, welcome to Teacher Hanji's channel. For today's video, we will illustrate the 6 trigonometric ratios, the sine, cosine, tangent, secant, cosecant, and cotangent. So, let's begin. The word trigonometry comes from the ancient Greek word trigon, meaning triangle, and metron, meaning measures. And the study of trigonometry involves triangle measurement. So for now, let us consider triangle ABC. So triangle ABC here is a right triangle. We have here side AB, side BC, and side AC. And these sides can be represented by small letters A, B, and C. And remember, if we get the trigonometric ratios of the given right triangle, we must know where is the hypotenuse, where is the opposite side, and where is the adjacent side with respect to the given angles. So this time, let us have the hypotenuse, opposite side, and adjacent side of angle B. So angle B here will be our reference angle, such that given in triangle ABC, the hypotenuse is the longest side of our triangle and it is the sides opposite to the right angles. Therefore, side C here is the hypotenuse of triangle ABC. Then, as for the opposite side, we must refer to our reference angle. Since the reference angle here is angle B, then the opposite side is side AC or side B. As for the adjacent side, this is the other side of the angle B here. Since angle B has sides AB and BC, and since AB is already the hypotenuse, then the adjacent side of angle B here is the side BC or side A here. So these are the hypotenuse, opposite side, and adjacent side with respect to angle B. So let us have angle A this time. Let's say that our reference angle is angle A. So again, the hypotenuse of triangle ABC is the side AB or C here, since this is the longest side and the side opposite to our right angles. Since our reference angle is angle A here, then the opposite side of angle here is side BC or A here. And that is the opposite side. And the adjacent side of angle A here is side AC or B here. So let us use this illustration to find the 6 trigonometric ratios with respect to angle A. Let us start first with the 3 basic geometric ratios, which are the sine, cosine, and tangent. So let us start first with sine A. Since our reference angle here is A, so we will look for the hypotenuse of the given triangle, the adjacent and opposite side with respect to angle A here. And sine A is equal to opposite over hypotenuse. So we know that opposite of angle A here is A, and the hypotenuse is C here, then sine A is equal to A over C. Next, we have cosine A. Cosine A is equal to adjacent over hypotenuse. With respect to angle A here, adjacent side is B, hypotenuse is C. Therefore, cosine A is equal to B over C. And for the third one, which is the tangent A, we will have opposite over adjacent. So again, with respect to angle A, the opposite side is A and the adjacent side is B. Therefore, tangent A is equal to A over B. So for us to easily remember and find the sine, cosine, and tangent with respect to the given angles, let us remember SOH. SOH means sine is equal to opposite over hypotenuse. So that is for the sine. Therefore, sine A is equal to A over C. Next, for cosine, we will have CAH. It means cosine equal to adjacent over hypotenuse, such that cosine A is equal to B over C. And for tangent, we will have TOA. It means tangent is equal to opposite over adjacent, such that tangent A is equal to A over B. And this is the first three geometric ratios. Since we need here 6 trigonometric ratios, using the same diagram here, then there are three other trigonometric ratios called the reciprocal trigonometric ratios. So when we say reciprocal, we will simply get the inverse of sine, cosine, and tangent. And these are the cosecant, secant, and cotangent. So let's start with cosecant. Cosecant is actually the reciprocal of sine here. So if sine is equal to opposite over hypotenuse, then cosecant is equal to hypotenuse over opposite. So you see, we simply get the inverse of this 2. And if we have here A over C, then cosecant A is equal to C over A. For the second, this is actually the reciprocal of cosine. Therefore, from cosine, we have here adjacent over hypotenuse. Then in second, we will have hypotenuse over adjacent. Such that secant A is equal to C over B, which is the inverse of B over C from cosine. And for the cotangent, this one is actually the reciprocal of tangent here. Therefore, cotangent A is equal to adjacent over is opposite, simply the inverse of tangent A here, which is opposite over adjacent. So if in tangent A we have here A over B, then in cotangent A we will have B over A. Therefore, cosecant A is equal to C over A. Secant A is equal to C over D, cotangent A is equal to B over A. So these are the 6 trigonometric ratios that we will discuss for this video. Let us have the following examples. Number 1. Find the values of 6 trigonometric ratios for the indicated angles. For figure number 1, theta here represents the acute angles of this right triangle, while for the second figure, alpha here represents the acute angles of this right triangle. So let us start finding the 6 trigonometric ratios of the first figure. Let us find the sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. So first, let us identify where is the hypotenuse, opposite side, and adjacent side with respect to angle theta here. So for this figure, the hypotenuse is this side, since it is the longest side and opposite to our right angle, while the adjacent side is the side which is also side of our angle theta here. Therefore, this is your adjacent side, and the opposite side is the side opposite to angle theta, which is this one. So since we already identified where is the adjacent side, opposite side, and the hypotenuse, let us now find the ratios of these trigonometric functions using the SOH-CAH-TOA. So let's start with SOH, in which we have sine opposite, which is 5, over hypotenuse, which is 13. Therefore, sine theta is equal to 5 over 13. Ka means cosine is equal to adjacent over hypotenuse. So our adjacent side is equal to 12. Hypotenuse is equal to 13. Therefore, cosine theta is equal to 12 over 13. Next is TOA. It means tangent is equal to opposite, which is 5, adjacent, which is equal to 12. Therefore, tangent theta is equal to 5 over 12. So this is the first 3 trigonometric ratios. Let us have the cosecant theta. Since we know that cosecant is the reciprocal of sine, then cosecant theta is equal to the reciprocal of 5 over 13, which is 13 over 5. secant theta is equal to the reciprocal of cosine theta. So if we have here 12 over 13, then secant theta is equal to 13 over 12. Cotangent theta is equal to the reciprocal of tangent theta. Therefore, if we have here 5 over 12, cotangent theta is equal to 12 over 5. And this is the 6 trigonometric ratios with respect to angle theta here. So let us have the second one. Alpha here is the acute angles. Then, let us get the sine alpha, cosine alpha, tangent alpha, cosecant alpha, secant alpha, and cotangent alpha. Let us identify first where is the hypotenuse, adjacent side, and opposite side. Given the right triangle here, then the hypotenuse is equal to 10. With respect to angle alpha here, the adjacent side is equal to 6. That's 1. And the opposite side is equal to 8. That's 1. Then let us now get the ratios of the following. Again, let us use SOH-CAH-TOA for us to easily find the ratio. Start with sine function. So we have sine is equal to opposite, which is equal to 8, over hypotenuse, which is equal to 10. Therefore, sine alpha is equal to 8 over 10, or it is equal to 4 over 5 in simplest form. Next, cosine alpha is equal to adjacent over hypotenuse. Therefore, we will have 6 over 10, which is equal to 3 over 5. Tangent alpha is equal to opposite, which is 8, over adjacent, which is 6. Then, we will have 8 over 6 is equal to 4 over 3. And that is for the first 3 trigonometric ratios. So let us have the last 3. To begin with cosecant alpha, which is the reciprocal of sine alpha here. So if we have here 8 over 10, then cosecant alpha is equal to 10 over 8 or 5 over 4. Secant alpha is equal to the reciprocal of cosine alpha, then this one is equal to 10 over 6, which is equal to 5 over 3. And for cotangent alpha, which is equal to the reciprocal of tangent alpha, this one is equal to 6 over 8, is equal to 3 over 4. And these are the 6 trigonometric ratios with respect to angle alpha here. So let us have example number 2. Solve for the missing side. Then find the 6 trigonometric ratios of each of the acute angles. So from this illustration, acute angles are angle Q and angle R. So it means we will get the 6 trigonometric ratios with respect to angle Q and angle R. So let's start first finding the missing length here, given that the legs of this right triangle is equal to 7 and 24. By applying the Pythagorean Theorem, which has the formula of c squared is equal to a squared plus b squared, such that c is the hypotenuse of our right triangle, while a and b are the legs of the given right triangle. Since the hypotenuse here is missing, such that a is equal to 7 and b is equal to 24. Therefore, we will have s squared is equal to 7 squared plus 24 squared. And this is equal to s squared is equal to 49 plus 576. 49 plus 576 is equal to 625. So for us to get the length of s here, then let us square both sides of our equation. The square root of s squared is equal to square root of 625, which will give us s is equal to 25. Therefore, the length of side QR here is equal to 25. So let us use that knowledge to answer the following. Get the 6 trigonometric ratios with respect to angle Q, such that hypotenuse of this right triangle is equal to 25. And 24 here is equal to the adjacent side with respect to angle Q Well, 7 is equal to the opposite side with respect to angle Q. Therefore, for us to get the sine Q, let us have the saw, in which we have opposite, which is equal to 7, and hypotenuse, which is equal to 25. Therefore, sine Q is equal to 7 over 25. Cosine Q is equal to CAH, in which we have adjacent, which is equal to 24, over hypotenuse, which is equal to 25. Therefore, we will have 24 over 25. And tangent Q, which is equal to TOA, in which we have opposite, which is 7, over adjacent, which is 24. Therefore, tangent Q is equal to 7 over 24. For the ratio of cosecant Q here, then we will have 25 over 7, which is simply the reciprocal of sine Q here. Second Q here is equal to 25 over 24, which is also reciprocal of cosine Q here. And cotangent Q is equal to the reciprocal of tangent Q here, in which this one is equal to 24 over 7. Aside from angle Q here, angle R is also an acute angle. Therefore, let us have the 6 trigonometric ratios with respect to angle R here. Since our reference angle here is angle R, then the adjacent side with respect to angle R is equal to 7, and the opposite side with respect to angle R is equal to 24, such that hypotenuse is equal to 25. So let us get the sine R using the saw, which means opposite, which is 24, over hypotenuse, which is 25. Therefore, sine R is equal to 24 over 25. Cosine R, which is CA, means adjacent, which is equal to 7, and hypotenuse, which is equal to 25. Therefore, cosine R is equal to 7 over 25. And for tangent R, we will have the TOA, in which we have the opposite side, which is equal to 24, and adjacent side, which is equal to 7. Therefore, tangent R is equal to 24 over 7. For the cosecant R, let us get the reciprocal of sine R, which is 25 over 24. Secant R here is equal to 25 over 7 from the reciprocal of cosine R here. And cotangent R is equal to 7 over 24 for the reciprocal of tangent R here. So that is how we find the trigonometric ratios of the given right triangles. Always remember to first identify the hypotenuse, adjacent side, and the opposite side with respect to the given angles. Remember the SOH-CAH-TOA for us to easily remember on how to get the ratio of sine, cosine, and tangent. So that's it for our video. Thank you for watching. Hope you learned from today's topic. Bye!